Hi everyone, Mrs. V here, and today we are going to be learning about strong and weak acids. So let's get our PowerPoint on and let's learn what the difference is. I was cruising around looking at some funny chemistry memes, as I tend to do, and I came across this one. And how funny is that? What? You don't get it? Well, hopefully by the end of this video, you'll be able to read it and laugh as well. Strong and weak acids. Let's have a look at some definitions. A strong acid is an acid that's completely ionized in water. Now that should come as no surprise to you because you really believe that all acids are completely ionized in water because we haven't really dealt with any other situation yet. But let's have a look at what that actually means. It means that all of the acid molecules have donated their proton to a water molecule, and that of course is going to make a hydronium ion. And therefore there are no acid molecules left. So all of the acid molecules have donated their proton, and you only have ions and water molecules in the solution. So if we look at an example of a strong acid, hydrochloric acid, HCl, when it dissolves in water, you can see the only thing present in the water are hydronium ions and chloride ions. There are no HCl molecules left in that solution. Well, what about weak acids then? A weak acid is one that's only partially ionized in water, and this is a new situation for us. It means only some of the acid molecules have donated their proton, and some of them just stayed as acid molecules. So now our solution contains ions. It has those molecules of acid that didn't get ionized and water molecules. So if we look over here, hydrogen fluoride is an example of a weak acid. When it reacts with water, we have hydrogen fluoride in the solution, we have fluoride ions, and we have hydronium ions. So we've got a mixture of everything that was present originally with all of the reaction products as well. So if we have a look at this special arrow that we use, when we're dealing with the ionization of a weak acid, we use this special arrow to show that the reaction has not gone to completion. This arrow is called an equilibrium arrow, and it just means that the reaction that we're looking at is reversible. That means not only here can hydrogen fluoride and water combine to make the products, but you can also get the hydronium ion and the fluoride ion combining to go back to the reactants. And therefore the arrow has half of the arrow for the reaction of hydrogen fluoride with water and half of it for the reaction of the hydronium ion with the fluoride ion. And both of those reactions are actually going on all the time. So what you have in your beaker then, you have hydrogen fluoride molecules, water molecules, fluoride ions, and hydronium ions. They will all be in that beaker together, and they'll all be continuing to react all the time. And this is called being in equilibrium. Now, when a reaction is in equilibrium, we have an equilibrium constant that will give us the ratio of products to reactants. So for an acid, this is called a Ka value. And the larger the Ka value, the stronger the acid is. Just means there are more hydronium ions and more anions being formed. So, of course, we have various strengths, even among the strong acids. So we have here the strongest of the acids, hydroiodic acid, Hi, with a Ka value of 3.16 times 10 to the 9th. That means that there are so many more products than reactants, so many more hydronium ions and iodide ions than there are hydrogen iodide and water left. So these are far in excess. And in fact, for our strong acids, we tend to assume that they have completely ionized. We assume that they've gone to 100%. In reality, that is probably not strictly the case, but we assume, particularly for calculations, that that has occurred. So what will we expect? If the Ka value is greater than 0.1 here, then we have a very strong acid. Moderately strong acids are in between 0.001 and 0.1. And then we have weak acids, very weak acids, and extremely weak acids. So you can actually get an idea from that Ka value how strong your acid is. But the ones that I would like you to remember as strong acids, I'd like you to remember that it's hydrochloric acid, nitric acid, and sulfuric acid. Of course, there are others, but what I want you to do is remember the acids that are strong of the acids that you generally use. Now, we have other terms that we use to describe acids, the terms concentrated and dilute. And one of the things that makes me very cranky is when people mix the terms up, strong and concentrated, and weak and dilute. So let's have a look. Let's be perfectly clear about what concentrated and dilute mean. So a concentrated acid just has less water added to it than a dilute acid. So you would expect the concentration of a concentrated acid to be, maybe higher than 5 moles per litre. Some of them can be really high though. Sulfuric acid is available as a 98% solution of sulfuric acid, and that's about 18 moles per litre. And we can see over here in the diagram that this acid will eat through paper. So we have a paper towel and it's being eaten away by the acid. A dilute acid though would have a concentration probably lower than 2 moles per litre. So there's no exact point where you can say that is dilute and that is concentrated. These are comparative terms. So we look at an acid that's more concentrated than another one or more dilute than another one, rather than absolutely that one is dilute. But there's a bit of a general idea there. If it's more than 5 moles per litre, you can call it concentrated. If it's less than 2 moles per litre, you can call it dilute. So I would love it if you guys did not mix up the terms strong and concentrated, and did not mix up the terms weak and dilute, because they mean different things. And in everyday life, people use them incorrectly all the time. Someone will say, how do you like your coffee? And someone will go, I like my coffee strong. No, you don't. You like your coffee concentrated. That's what you really mean. So now that we're chemists, we're going to use the proper terms. Let's look at what it means. So here, this is a really common exam question, actually, having these 4 beakers presented, and you're asked to identify which one is the strong acid, which one is the weak acid, which is the concentrated, etc., etc. So here we have a concentrated solution of a strong acid. So the concentrated bit means that there are lots of particles. And the strong part is all about the fact that the particles are all ions. There are no unionized acid molecules. Okay, compare that to a dilute solution of a strong acid here, a dilute solution of a strong acid, you can see it's still all ions because it's still strong. So strong, all ions, but dilute simply means less particles. All right, let's have a look at a concentrated solution of a weak acid. So a concentrated solution of a weak acid, the concentrated means lots of particles. And the weak acid means that not only do we have hydronium ions and the anions from the acid, but we also have unionized acid molecules. So that tells us straight away that that is a weak acid. And of course, a dilute solution of a weak acid, that's simply going to have hydronium ions, anions, unionized molecules, but because it's dilute, there are not many particles. So let's use those terms correctly from this point on. And now I have that meme for you. H3PO4, phosphoric acid is a weak acid, and sulfuric acid is a strong acid. And I think we get it now. So there you have it. Some definitions surrounding acids and bases, strong versus weak, dilute versus concentrated. We're never going to mix those up again. If you found this video useful, if you found that it's made you understand those terms a little bit better, then please consider giving the video a like. And as always, to find out even more about this wonderful subject of chemistry, then please subscribe to my channel. Watch a few more videos. I am going to see you guys in the next video.